Hello. Today we are going to be talking about nitrogen fixation in legumes because legumes are the easiest, I'm not gonna lie. First, we need a plant. We're gonna give ourselves a nice little legume. Here's our little pea plant. Could be kudzu, could be a pea. For all we know, it could be Cercis canadensis. But the top part, that's just like a regular plant, and for all our purposes, we're focused on the root of the matter. And on legume roots, there are often symbiotic relationships with the bacteria in the soil. And when those roots encounter the bacteria, oftentimes they have a process of nodulization with these nodules being areas that this bacteria are allowed to colonize inside of the root. That basically acts as a way for them to have more surface area and be protected and be able to work closer together because they're in closer distance. And these bacteria in here, they need sugar. So the plant supplies them with sugar. Let's see. Back here. Plant. That gives the bacteria sugar and a safe space. Safety. Sugar and safety. The bacteria from the environment. This is why soil aeration is important, people. From the environment, the bacteria get oxygen. Because everything needs oxygen to survive. The bacteria, in change, give the plant nitrogen, specifically in the forms of NH3, NH4 plus, and NO2, or NO3 minus. Ammonia, ammonium, and nitrate. These are the main ways that the plant, this legume, can get nitrogen. Because in the atmosphere, there's a bunch of N2, where it's two nitrogens, but they have a triple bond, which is difficult to break. The only, well, really not the only, but the main ways that this gets broken is through the bacteria and lightning, because it takes a lot of energy to break the triple bond. So it gets into from there. Now, sometimes, especially because ammonia is the easiest one to make. So normally it's made by our little, rhizobia. One second. Rhizobia help to make the ammonia. Because ammonia and ammonium, they're the easiest one to make. Ammonification is the proper word for that. They turn this into that. NH3 or NH4 plus. And then we also have the brachyrhizobia, which do a similar thing. They also help make nitrate. But the legume works with the bacteria. The plant gives them sugar in a safe area, and the bacteria help give them nitrogen. But they give them enough nitrogen, they have more than they need. Hence the reason why you don't really have to fertilize nitrogen for legumes. And that's why legumes and their symbiotic relationship with bacteria help to increase the nitrogen in the soil, thereby helping to give more plants around a chance to have their proper nitrogen. But this fun part, you can't forget that that it's not just a ton of ammonia and nitrates. They don't just stay there. Some of the ammonia, the NH3 and NH4 plus, they go and they're very volatile. And so they volatilization. I don't think you spelled that correctly, but volatilization, where the ammonia and ammonium go back into the environment and become nitrogen again. While the nitrate, the NO3 minus, the stuff that's not used by the plant immediately, it tends to get leached out into the groundwater. Now, normally with this, there's not usually too much of a problem with the nitrates getting into the groundwater because they're such small concentration. That's why when we artificially fertilize areas and give them too much nitrogen to properly function, that groundwater becomes high nitrogen, and when wherever it pops up, springs especially or ponds, you get eutrophication. Where all that algae gets all that nitrogen, starts bulking up, getting a ton, and then it dies and it dies and it sucks the oxygen out of the water and it kills everything around, creating dead zones. But those legumes, they know how to fix nitrogen with their help with the little friendly bacteria. And this bacteria are all over the soil. They're just in much higher concentrations around legumes because, these little nodules. And like these roots be covered in nodules. They'll produce more nitrogen for them. Hence the reason why legumes, they're super efficient at getting nitrogen to the soil. Pretty much a lot of the plants in the Fabaceae family. So like let's see, red buds or Cercis densis or peas or beans or kudzu, fortunately, or what's a good example? Oh yeah, mimosa. Stuff like this, because of that, they're part of the Fabaceae family and they can have this little special nitrogen fixation relationship with bacteria. They're able to be just fine when there's no nitrogen in the soil because they make it. Very, very important strategy. And in fact, some organisms, there's certain algae, I believe the University of Washington figured this out. There's this type of algae that absorbed a bacteria that fixes nitrogen and created the nitroplast. Which, if you remember, is the exact same process that got us the chloroplast in the mitochondria, the powerhouse of the cell. So yeah, that's nitrogen fixation in a pretty simple and easily consumable way, I wish you good gardening and have a very good Halloween.